So we're going to go ahead and jump in. Just a couple of things today to get us started for some housekeeping issues. So first of all, I'm Becky Anderson. I've been working with schools for about 30 years now, helping and also industry. I'm a hazmat chemist by trade. And I've also done some time as an emergency responder. So, and the primary focus for these webinars is to help you minimize risk in the classroom by making good decisions, by identifying which chemicals and products you should have in the classroom and which ones may present too much risk. So that's what we're going to be focused on today, is understanding how do we assess that risk and then making choices. And then I'm also going to give you a heads up on some of the areas that we found that have been troublesome. So I want to stop for just a second and say thank you to Vicki Davis. She's with the Upper Valley Lake Sunapee Regional Planning Commission, and Vicki is the one that applied for this grant from EPA and that's allowed us to do these webinars. So thanks to Vicki. Also thanks to EPA Region 1 for hosting them on Zoom. That you guys have just been fantastic and being very helpful with making sure that all of our technology works well. And then finally, you'll see some of the photos today and some of the information today on the slides is from Dave Waddell. Dave Waddell was a leader in the Rehab the Lab processes that occurred throughout schools across the United States. He taught me a lot of what I know about what to look for and risk mitigation in schools. He is retired now from King County government, and I just wanted to shout out to him and say thank you as well. He's provided me with endless resources that are always outstanding. So thanks also to Dave, and I truly hope he's enjoying retirement. So, all right, we're going to go ahead and get started. Just a few more little housekeeping things. If you have trouble today, this is kind of a little cheat sheet from EPA provided to us. So I will be paying attention to the question and answer box, but the chat box is unavailable to you. So if you do have any questions or you need additional information, please put that information in the question and answer box, and I'll try to get to it either during the presentation or at the end of the presentation. Also, we don't have the raise hand thing activated. And if you are having troubles hearing, you can check the audio or the sound button. Everyone is muted, but there might be some settings or something on that if you're having trouble hearing today. I do know that in Iowa, we're having a huge communication outage due to some problems with some fiber optic lines. It appears to me that everything is working okay from this end, but I just want to, kind of give you a heads up on that as well. Okay, topics for today. So we're going to talk about history and a little bit of what we have found in schools throughout the United States. And there have been some common themes that we've seen over the last, probably 20 years or so. The first thing that we see is a lack of understanding of chemical risk, and also a lack of understanding of how to assess that. How do you evaluate a chemical to determine if it's too risky in your classroom? Second thing is we have questions about, well, can I even use these products? And there isn't a whole lot of guidance out there. It's truly what we found is that evaluation of risk and inclusion of chemicals in curriculum is typically left up to the teacher. So we really want to make sure that we're helping you today understand chemical risk and how you can evaluate it. And then also we want you to understand exposures and the risks associated with exposure to various chemicals and how we can minimize those. One of the things I found as I was doing research on the current state of industrial technology is that you guys aren't called industrial technology. We have a lot of areas of the country now that have switched that to career and technical education. So CTE is the abbreviation that I came across in several states. So I want you to know I've kind of modified things, but when I refer to CTE, that is industrial technology. And one of the things that I found is that there are so many different areas that you can direct students to in curriculum. It's going to be tough for us to cover a lot of those. So what we're going to do instead is focus on just kind of a generic approach to how do you evaluate whether or not chemicals should be in your classroom. Final housekeeping item, make sure you post any questions or comments through the question and answer, and I'll try to get through those as we're going through the presentation today. If you have additional questions, you'll have my contact information at the end, and you are absolutely more than welcome to reach out to me. I know this is particularly a tough time of year to get everybody to participate and to take an hour out of schedules. I know we've already got a lot of schools that have released for the year for the summer. So if you are watching this over the summer, or you're watching it first thing in the fall, please, if you do have any questions, it doesn't matter how far out it is, please reach out and I'll do the best that I can to help you evaluate whether or not something, either a process or a chemical, should be used in your classroom based on the safety measures that you have in place. Also, just as a final note, this information is current as far as for spring of 2024. The regulations in this area do change. And so I want to make sure that if we've got somebody that's watching this in 2034, I want to make sure that you review the current regulations and what are the current requirements for you. So this is this webinar series was presented in 2024. Please make sure that you're aware of the current situation with your regulations and what you fall under. All right, so quick history lesson. I've been in, oh God, I don't even know how many, 400, 500 schools throughout the nation over the last 20, 25 years, just evaluating what chemicals are present and what challenges we're finding. And we see a lot of the same themes. We see a lot of the common themes. And one is that we frequently have no clear disposal plan for unwanted chemicals. A lot of times if we have teacher turnover, we also have no succession planning. And that succession planning needs to include, okay, if we had a teacher that was here in our school for 10, 15, 20 years and had certain processes that they did and certain chemicals that they used, when they leave, that new incoming teacher frequently walks in right now to kind of a big mess. So we really need to put into place some parameters on how those chemicals can be disposed of, if there are any that are valuable to still continue to keep around. But right now, we don't really have a lot of those practices in place. We also have little to no education on what are acute or chronic health effects or environmental impacts associated with various chemicals. And one of the things that I've seen change over the last 20 years is that chemicals that we saw 20 years ago may not be appropriate for us to use in schools now. And in fact, I've seen that a lot. The practices have changed. We've tried to minimize risk because we've increased our understanding of how dangerous those chemicals are. And then finally, the last thing I'm going to ask you is please make sure that you have a policy that addresses donations. If you request specific chemicals for a specific process and parents or businesses donate those chemicals, make sure that you truly do have a use for those chemicals and that you're not storing years worth, decades worth of chemicals on site. We have seen in a number of occasions where schools have accepted chemicals from businesses, and really what they were doing was just taking hazardous waste from the businesses that the businesses didn't want to pay for. So please make sure if you do accept donations in that you have a very clear use for those. If you do not have a use for them, tell the business that no, you're not interested. Or better yet, put in place a policy that says nobody's going to accept donated chemicals unless there is a request that's put out for a specific process. Result of all these different challenges that we've seen is that we have large quantities of unwanted, unusable, unnecessary supplies. We see unsafe storage of these chemicals. And again, no clear disposal process. When we do have clear disposal, it's usually very expensive, and that makes it very prohibitive for schools. So before you choose to bring in a new chemical or a new process, I'm going to ask that you evaluate this. And if it's a chemical that you decide 2 years from now you don't want, how are you going to get rid of that chemical? And how much is it going to cost to get rid of that chemical? We also see little personal protective equipment available and very few engineering controls such as fume hoods or snorkel hoods to pull inhalation hazards away from students and teachers. As a result of that, we really need to make sure that we're balancing the risk associated with the chemicals, the type of exposure that the chemical can present to us, and the safety measures that we have in place. And we have to talk about and balance all of those things to make sure that we're making good choices in our schools. All right, different chemicals that we've identified during assessments that, frankly, these go to the top of my list of chemicals of concern. First are volatile organic compounds in inhalation toxins. And what I mean by that is these are typically like spray adhesives that have combinations of solvents in them. So they're aerosolized solvents. You can see in the picture on the bottom left, spray adhesive that contains hexane, acetone, propane, butane, and toluene. When we combine hexane and acetone, that is a terrible combination of chemicals. It can be very neurotoxic. And one of the things we'll talk about is that little bodies or young bodies are impacted differently from these toxins than older bodies. Their children and young adults have less ability to clear these toxins from their systems. Their metabolisms are different also. So they can be dramatically impacted by even small exposures to chemicals like this. The next one is toxic metals, lead, chromium, beryllium. The predominant place that we see these are in pigmented types of clay or concrete. I've seen lately, we've got a lot of people that are doing concrete colorants. A lot of times those pigments will have heavy metals in them or toxic metals in them that are bioaccumulative. We also see toxic metals. Of course, we still continue to see them in welding and soldering operations. And then finally, we see concentrated acids. The predominant one that I see in a lot of industrial tech or career and technical education areas is sulfuric acid, which is battery acid. And we do still see that, and it's in really difficult to manage containers, little polypropylene plastic containers. And usually when you open them, they're very difficult to close or they can't close. So those present us with a lot of risk as well. Now, where we're going to start today is the evaluation of chemical risk. And you'll see over the next series of slides, I'm going to talk you through how you can use resources to evaluate whether or not a chemical is too risky, or if you choose to use the chemical anyway and it does present risks, how are you going to protect yourself and your students from any exposures to that chemical? So the first thing is we've got a wide spectrum of skills that are taught in CTE classrooms now. I'm not going to try to go through all of the different operations. We don't have time for that. And frankly, I know I would miss a bunch of them. There are thousands and thousands of products available. So I also am not going to give you these are bad products list. All right. What I'm going to do is I'm going to teach you the strategy for evaluating those products. There's little opportunity for safety training. This is one of the few classes that I've seen that offers this type of safety training. So again, if you're confused, if you get into the muck and you really start digging into safety data sheets or evaluation of chemicals and you get confused, reach out to me. I'm happy to help you with ferreting through all of that information and trying to understand it. So first thing that we're going to concentrate on is defining what is toxic, understanding how exposures occur, and also understanding that, we don't have all the answers with this stuff. Typically, the evaluation of chemicals is done one ingredient at a time. And so if we have a chemical that has a blend of 5 ingredients, we have no idea what the synergistic effects or impacts of all 5 of those chemicals are. The way that chemicals are evaluated by industry is on a chemical by chemical basis. And the toxicology or the toxicity of that chemical is evaluated based on the parameters of a 180-pound male. That is, I think that the average age is 30. So a 30-year-old 180-pound male is what toxicity is evaluated based on. So if we're dealing with students that are in junior high, if we're dealing with high school students, we've got kids that weigh 120 pounds. They're going to be impacted differently. The age, the weight of the person, all of those factors cause chemicals to impact the body differently. And we frequently can't predict that. Knowing what the toxicity is for a 180-pound, 30-year-old male helps us to get a glimpse of whether or not this is a chemical that we should have in class, but it does not give us all the answers. And when we have a product that has multiple chemicals in it, again, frequently those products are not, they're only evaluated on a chemical by chemical basis. They are not evaluated as a mix. So we need to always keep that in mind as we're making decisions and making choices on what we're using in our room. We want to make sure that we're identifying all the different health effects. And one of the things I always want you to keep in mind is as the years have gone by, as the decades have gone by, we are exposed to a very different level of chemicals in all aspects of our lives than our grandparents, our great-grandparents, people in the 1900s, people in the 1920s. We are now exposed to a number of chemicals. And again, frequently we don't have a good understanding of how those chemicals are impacting us. As we learn more information and use chemicals more, we do get additional data that helps us determine whether or not they're toxic. One example of this would be PCBs, polychlorinated biphenyls. These are chemicals that were commonly added to everything from oils to paints in the 1960s, 40s, 50s, 60s, and up till about the 1970s. And then we started figuring out that, whoa, PCBs are bad news for humans. They're bioaccumulative and they cause cancer and a whole other host of health issues. So since that time, since about the 1980s, we've eliminated a lot of use of PCBs. That's just one example. We also used to, use mercury for a lot of things. And now we know that mercury is also bioaccumulative and leads to significant health issues. So that's another thing that we've started working away from. We no longer add mercury to paints as an antifungal. We actually used to add mercury to wrestling room floors as an antifungal. And thank goodness we no longer do that. But what that's done is create terrible challenges for us from a health perspective and then also from a hazardous waste disposal perspective. It's very, very expensive. Over the years, I've helped a couple of schools get rid of their wrestling room floors, and they've been outrageously expensive when we find high levels of mercury in them. We always need to keep in mind that young bodies are impacted more substantially by chemicals than older bodies, just because of the metabolic differences and the size differences. So while we understand some exposures and we understand how some chemicals react with our bodies, we still do not understand all of them. So we always need to approach this with just a specific level of caution. So let's start talking about how we're actually going to evaluate this. There are 4 different routes of exposure that industrial hygienists have identified and that they concentrate on. There's inhalation, absorption, or contact. So for example, absorption, contact, let's say I am working with some acetone and I dump a little extra on my hand. Well, not only does it affect the surface, which is a contact exposure, but also some of that acetone is going to absorb through my skin into my body. That's an absorption hazard. Inhalation hazards, predominantly those are things like aerosols. They can also be, though, vapors that are being emitted by certain chemicals because they have a low flash point. Things like gasoline. So when we're working with gasoline, it's emitting a lot of vapors at ambient temperature. When you stand over it, when you smell that gasoline, when you inhale the gasoline, that gasoline goes into your body and can have some significant health effects for you. Inhalation, absorption, and contact are the primary ones that we concern ourselves with at school. Ingestion and injection, I truly hope that you don't have to deal with any of this, but I have had teachers tell me that they've had students that have wanted to taste things and dump things. And so we have to also be very cautious when it comes to exposure by ingestion and injection to make sure that our chemicals are locked down so that we don't have any inadvertent dangerous acts performed by students with the chemicals that we're responsible for. Most recently, or most frequently, we're interested in evaluating inhalation and absorption impacts on the chemicals that we're using in school. And again, as I said before, We have industrial hygienists and epidemiologists that are evaluating these chemicals, but they don't always know how they're going to impact small bodies or how multiple chemicals mixed together are going to behave and what health risks they're going to present to us. So where do we start with all this stuff? Well, what I'm going to encourage you to do is, first of all, we're going to go through what are the OSHA regulations. So in Vermont, public employees, including teachers, are covered by OSHA regulations, which means that you have to meet some of those OSHA requirements. In New Hampshire, it's a little bit different. New Hampshire does not have a state OSHA program. However, the Department of Labor has stepped in and said, you know what? We're going to adopt some of those OSHA requirements. So both Vermont and New Hampshire employees are operating under what's called the Hazard Communication Standard. If you're really bored or if you have insomnia, you can go out to Google and type in 29 CFR 1910.1200. And that is all of the regulations that are addressed, all of the requirements that are included in the Hazard Communication Standard. And we're going to talk a little bit about this because this is actually, in my opinion, beneficial to you because it requires you to learn some things and it requires you to have some tools to evaluate risk. The key requirements of the HAZCOM program or the Hazard Communication Program include safety data sheets. So for any chemicals that you're bringing into your classroom, you're required to have a safety data sheet. The exemption for this or the exclusion for this are chemicals that are used in households or are readily available. So things like, a good example would be like whiteout, or a good example might be simple green. All right, those you are not required to have safety data sheets for because they're available to consumers, general consumers. What I'm going to tell you though is you're going to want to have that safety data sheet, and most industry does have those. So the manufacturers have put together safety data sheets for things like that. So if you have chemicals, particularly mixtures, they should come to you with safety data sheets. If they do not, when you order them, if they don't come with safety data sheets, what you can do is go out to the company's websites, and almost all manufacturers now have safety data sheets available to you. The second thing that's required by the Hazard Communication Standard is labeled containers. And there are specific requirements for the labeling. They're very challenging. I'm just going to put that out there up front. They're very challenging. We have to have pictograms, signal words, hazard and precautionary statements, the name of the product or the product identifier, and the supplier or manufacturer information. All of that needs to be on labels. So what I usually tell school folks is, you know what? This is a really good reason for you to leave chemicals in their original containers when you receive them. Because when those manufacturers ship them, they have to have all of this information on them if they're going into industry. If these are for consumers, so you can buy them at your local box store, probably not going to have this information on them. It's a disconnect between OSHA, which governs worker safety, and the Consumer Product Safety Commission, which watches out for consumers. So they govern differently. The labeling requirements are different. In a school, though, because you are considered part of the OSHA, under the OSHA umbrella, you need to make sure all of your containers are labeled. So if you order something that's concentrated and dilute it down into spray bottles, you need to ask that manufacturer if they can send you some of those labels so you can put them on the container. Unfortunately, we're no longer in the days where we can put a piece of duct tape on a spray bottle and write a name on the mark using a marker. Just doesn't work anymore in OSHA. That is an OSHA violation. The next thing that is included in the Hazard Communication Program are pictograms. I'd like you to learn these. There are 9 of them, and they are at a glance identification of risk pictures. And you'll see them over on the left side there. You can actually buy sheets of these from like Avery. You can also print them off on Avery labels. so that if you do move something that's concentrated into a more dilute container, you can print off the pictograms and put them on the container. And that is one of the requirements under OSHA. So there are 9 different pictograms. I would encourage you to make sure that you're familiar with all of those. And frankly, that's a really good exercise for students as well. This is one of the things that they are going to run into as they move into industry. So for students to understand and know what the risks are associated with the different pictograms before they have a job in industry, that's going to give them a leg up. That's part of their industrial onboard training. And in almost all cases, should be. And so for them to understand that would really be a benefit to them. The next requirement for HAZCOM is training. So probably, I'm guessing at the beginning of the year, when you're doing all of your back to school training, hazard communication is going to be included in that. Each facility is also required to have a written program with an inventory. Now, the key for you guys to hear there is the word inventory. Please make sure that you have a list or an inventory of the chemicals that you use, and then collect the safety data sheets associated with them. You can collect them electronically, throw them into a little file folder. That's acceptable under OSHA anymore. Or you can have paper copies. Either one is acceptable. And in New Hampshire, there's specific emphasis from the Department of Labor that public sector employees are required to maintain a safe work environment and to provide training and tools necessary to maintain that safe environment. That's one of the phrases that the Department of Labor has adopted and that you need to be familiar with. Now, when we're using safety data sheets, these are going to provide us with really good information. In 2016, we had a very big change to safety data sheets, and now they are all formatted where they have 16 different sections of information. They're really long. So I'm going to teach you kind of the cheat sheet, chemistry for non-chemists way of evaluating a safety data sheet today. Hopefully it will save some time, and it'll also tell you the exact information that you need right away. The example that I'm going to go through is methanol. Now, a lot of times folks will go, well, methanol, I don't have any methanol. Well, if you use windshield washer solution, whether you use it at home or at school or in an automotive class, windshield washer solution is almost always made predominantly of methanol. Okay, so this is something that's very common. One of the things that I get a lot of surprised looks from teachers is the level of toxicity of windshield washer solution. So when we're evaluating risk, we're going to take that safety data sheet. And remember, the safety data sheet typically is only going to have one ingredient on it. Sometimes we'll have a safety data sheet that will have all the ingredients of a mixture on it, but not always. For this one, windshield washer solution probably just has one ingredient. Maybe there's a small amount of dye in there as well. First place I'm going to look when I'm evaluating a safety data sheet for risk is I'm going to turn to section 2. Section 2 immediately starts off with the list of the different hazards associated with the chemical. The next part of it will be the pictograms indicating at a glance what the risks are. And this is where I really spend a lot of time, is in the GHS classifications of the hazard statements. And I will go through and read all of the hazard statements so that I have a really good way to evaluate whether or not this is something that I want around me, and whether or not this is something that I need to have, extra safety equipment for. So let's take a look at methanol. So you'll see on the right side, you'll see the section 6 for methanol, or section 2 for methanol. And it starts off with a flammability, an acute toxin, and a chronic or respiratory toxin pictogram. The hazard statements include that it's highly flammable, it's toxic if swallowed, in contact with skin, or if inhaled. So it can be toxic even if we just come into contact with it on the skin. There are 2 different signal words that you'll see. You'll see danger and warning. Danger is more risky than warning. This particular methanol safety data sheet says danger. So I know just from looking at that, that this is a really risky chemical. And again, we're talking about windshield washer solution here. Precautionary statements are going to give us some guidance on how do we even handle this stuff. Keep it away from heat, keep the container closed, implement bonding and grounding because we can have static charge that leads to a fire if we're transferring safe windshield washer solution. Use non-sparking tools, take precautionary measures against static discharge, and then do not breathe the mist or vapors. Pretty crazy that all of that is listed as the risk for windshield washer solution. This is the way that we begin to evaluate risks. So the first question that pops into my mind is, well, shoot, how am I going to wash my windshield on my car now? Am I going to keep using this? The next section that I'm going to look at is section 8. Okay. Remember, we've got 16 sections. Safety data sheets are long. We're just going to cut to the chase. We're going to look at section 2 for all the hazards. We're going to look at section 8. That's going to tell us the exposure controls. Now I'm going to teach you my little rule of thumb that I use in industry. This is what I talk with a lot of industrial chemical folks about. The lower the numbers, it doesn't matter if you know all of these abbreviations, TWA, time weighted average, STEL, REL, PEL. It doesn't matter if you know all of those abbreviations. What you need to keep in mind is the lower those numbers are, the quicker and more dangerous that chemical is, and it's going to try to hurt you. The lower the number, the more dangerous and the more likelihood you could have negative health impacts from exposure to this chemical. I have 3 different zones or 3 different pools that I put chemicals in. If I have a chemical and I'm looking in section 8 of the safety data sheet and it has any of those numbers, TWA, STEL, REL, PEL, of 50 parts per million or lower, and I want you to know that parts per million is also indicated here as milligrams per meter cubed. 50 parts per million or less, that is a really dangerous chemical. This is in my red zone, or this is a red flag chemical for me. I'm going to really think about whether or not I want to deal with this chemical. I'm going to also evaluate how I can protect myself and my students from this chemical. This is one that would go on my, do I really want this in my classroom list? And I'd have to think about it a lot. The next zone is 50 to 500 parts per million. That's the yellow zone. That means, you know what? There's some toxicity here. This is a chemical that I need to have respect for, pay attention to, and know how to protect myself from. And then if we're over 500 parts per million, that's my green flag zone. I'm still going to respect that this is a chemical. This is not something I'm going to pour over my Cheerios in the morning. I'm still going to respect that this is a chemical, and I have to make sure that I'm protecting myself from any inadvertent exposures to it. But it's a good choice. It's a good choice to have in class. Way better than my red zone chemicals. All right? If anybody has any questions about that, please make sure you reach out to me. Just some examples. So on the methanol safety data sheet that I've been talking about, the TWA long-term exposure limit is 200 parts per million cutaneous absorption. That means skin absorption. 200 parts per million. That's not a lot. Definitely in my yellow zone. I really don't want to get that methanol on my hands, on my body, because 200 parts per million is really not that much. The easiest way to gauge this is 1 part per million is about the equivalent of 1 grain of sand in a 3 foot by 3 foot box. The young lady on the right side of the screen is in a 3 foot by 3 foot box. If we put 1 grain of sand in there and she's exposed to it, that's 1 part per million. So I want you to imagine counting out 200 grains of sand and then putting them in that box with that young lady. Doesn't take much exposure at all to hit that 200 grains of salt. And that's That's the threshold limit that industrial hygienists say is safe. Anything more than that, bad news. So again, we're in the yellow zone on this methanol. And one of the ways that I'm going to prevent exposure is I'm not going to work with it without some chemical resistant gloves on. I'm going to put on some disposable nitrile gloves, and I'm going to make sure that I don't spill it on my hands, spill it on my body, spill it on my clothes. I'm also going to make sure that I'm not breathing any of it in. There's going to be a lot of vapors coming off of it. It has a very low flash point. If we go to section 9, that's going to tell us these physical properties of the chemical as well. Now, this is a lot of technical information. Okay, what you need to think about here, there are 3 pieces of data that I pull out of this table immediately. One is flash point. If I've got a chemical that I'm dealing with and it has a flash point of less than 140 degrees Fahrenheit, it's considered a hazardous waste if I go to get rid of it by EPA. In the case of methanol, we have a flash point of 49 degrees Fahrenheit. What that means is that at 49 degrees Fahrenheit, which is pretty chilly, that chemical is off-gassing enough that it could cause a fire. It's also, because it's less than 140 degrees Fahrenheit, it's considered an EPA hazardous waste. So if I get to the end of the school year and all of my vehicles have been filled up with windshield washer solution and I still have a half a container left, can't dump it out, can't throw it in the trash, can't dump it down the drain. We want to make sure that we're continuing to use that for its intended purpose. We also need to remember that it's pretty highly flammable. So if we are going to store it until the next school year, we need to keep it in a flammables cabinet. The next piece of information that I'm going to look for is I'm going to look for the pH. pH is the measure of whether or not it's acidic or basic. If I've got a chemical with a pH of less than 2.0 or greater than 12.5, it is an EPA corrosive. Example of this would be that battery acid or sulfuric acid. It's going to have a pH of about 1, very dangerous. Burns just by splashing, creates a lot of risk. This is not a chemical that we want to have around a lot. We may need to have some of it to repair batteries, but it's not something that we want to keep around. And this is one that I would be really cautious about whether or not we let students handle this unless they have the appropriate protective equipment on. Safety glasses are even better, chemical resistant goggles, chemical resistant gloves, long sleeves, long pants, and probably a chemical apron. Something to protect them from any splashes from that battery acid. If this information is not complete, so if you open up your safety data sheet and it doesn't have any Section 8 data or Section 9 data, you need to really think about whether or not this is a chemical that you want in your classroom. What that means is that our industry folks have not filled in the information and they've not provided you with the information to keep you and your students safe. So I would be really cautious about whether or not I would continue to use a chemical that does not have a complete safety data sheet information on it. Safety data sheets are long. To summarize, we want to start with Section 2, read the hazards, know the pictograms. Then we go to Section 3, and that's where it tells us whether or not what the percentages of ingredients are. And we want to look and see if it adds up to 100%. We also want to look at Section 8, which is exposure control. That's where we have all those abbreviations, IDLH, TWA, STEL, PEL. The only thing you need to remember on that section is that lower is bad. Don't let it overwhelm you. Lower numbers are bad. And think about the 3 different pools. Up to 50 parts per million, red zone. 5,500 parts per million, yellow zone. 500 and above, green zone, that's a chemical that we should be okay to use. And then section 9, which is flashpoint and pH, will also give you some waste disposal considerations. If you've got something with if you've got the choice, let's say between a parts washer with a low flash point of 125 or a parts washer with a flash point of 160. At the 160 level, EPA doesn't consider that hazardous waste. We still should not just dump it down the drain. We still need to look for good outlets that are safe, but it's not regulated as a hazardous waste, which requires expensive disposal. The way that we have to think about these chemicals, and one of the best ways that I've identified over the years to really evaluate these, actually comes from OSHA. It's called the OSHA hierarchy of controls. And in safety training with OSHA, you might hear them use this concept pretty frequently. Basically, what OSHA is asking us is, there are certain ways, certain strategies that we can minimize risk. The first thing that we can do that is most effective is to eliminate and not choose things that are toxic or dangerous. The next step on the hierarchy controls, if we can't eliminate a chemical, can we substitute something that's less hazardous for it? Can we substitute something? Can we find an alternate chemical that is less hazardous? The next two steps, engineering controls and administrative controls, those revolve around removing the hazards away from us. So can we use a fume hood? Can we use a fan that blows behind us and pushes the vapors away from us? And then the final step in the OSHA hierarchy controls is to rely on personal protective equipment. Anytime that I'm teaching this in industry, I want to be clear that personal protective equipment is just the last ditch effort. If there are any other choices you can make, if there are anything that you can, any chemicals that you can eliminate or substitute, if there are protective measures that you can work with your facilities department to get in place, such as engineering controls or administrative controls, those are far better choices than just relying on a thin piece of plastic to protect you from something dangerous. And that's what personal protective equipment is. It's a thin piece of plastic that prevents you from having exposures. Also prevents your students from having exposures. This is a really good example of an engineering control. As you can see here, we've got a young girl and she's doing some stained glass work. She's actually soldering. And anytime she's soldering, what we have, you can see in front of her, is a negative pressure ventilation system. So it's sucking those vapors away from her so she doesn't breathe them in. That's an engineering control to prevent any exposure to inhalation hazards coming off of that soldering. Really good option. We're going to kind of switch over now to understanding and minimizing exposures. The primary thing that I hear from teachers all over the place is inhalation exposures are a big concern to them. How do we prevent breathing in this kind of stuff? There are some very simple things you can do. There are very inexpensive options that you can implement in your classroom, or you can go with more expensive ones if you work closely with your facilities department. This would be things like HEPA filters. The key thing here, what we want to do is we want to move those vapors, move any inhalation risk away from your face, away from students, away from how you're breathing. We can either do that by pushing the vapors away or by sucking the vapors out. There are a lot of different choices. I would encourage you to work with your facilities folks if you do have a process that you use that creates some inhalation risk. All right, I am going to spend the rest of the time today talking about some of the specific risks that we see. We don't have time to go over all of the different risks, but I do want to start. I want to go through 4 of them. The first one we're going to start with are volatile organic compounds or solvents, solvent vapors, spray adhesives. These are chemicals that are high level inhalation risks, particularly when we have a combination of hexane and toluene. I showed you that spray adhesive that had both hexane and toluene in it. That combination in particular is very dangerous. So you want to check all of your aerosols. If you have something that's a hexane toluene combination, it's neurotoxic and you do not want to have that in your classroom. You don't need to breathe it, let alone your students. Anything else that is a solvent and an inhalation risk or an aerosolized solvent, we want to make sure that we're spraying upwind. We want to keep our lungs away from it. If at all possible, we really want to use a spray booth and we want to suck those vapors away from us. If we are going to use anything that has solvents or volatile organic compounds, we want to make sure that we're using chemical resistant gloves, goggles, and safety glasses. And these are chemicals that we should never use around very young children. The neurotoxic effects and the lung impacts can be especially dangerous. Okay, solvents are used to dissolve, deliver, remove materials. One of the things I want you to keep in mind is that the more volatile, the lower the flash point, the more we have volatilization or we have evaporation of those chemicals. And if you're smelling them, you're breathing them, those chemicals are going right into your body. Anytime we're pulling those chemicals into our bodies, we have health impacts. So we want to avoid those as much as possible. Lacquer thinner is probably one of the most hazardous. And even if you've moved, like if you have a woodworking class and you've moved to odorless chemicals, those are still less volatile. So they're going to have a higher flash point. They're less volatile. You're breathing less of that chemical, but a lot of them still have highly toxic and flammable ingredients. So please make sure that you're appropriately evaluating the risk of the chemicals that you're using that are solvents. Okay, next we're going to switch gears and we're going to talk about toxic metals. Predominant areas that we find toxic metals include welding and soldering, and then also in painting or pigment work. I've seen a lot of increase in pigments used to colorize cement over the last few years. Please keep in mind that you want to look at those and make absolutely certain that they do not have any toxic metals in them. The list of metals that are dangerous, and this isn't all inclusive, but it hits the top ones that we typically see, are antimony, cadmium. Cadmium is very frequently seen. Cobalt, manganese, nickel, arsenic, chromium, lead, and mercury. The key thing with these particular metals is that if you inhale them, whether it's through welding that you have, let's see, the primary area that I see this as a problem is in stainless steel welding. Or if you're soldering, sometimes the fluxes or the solder itself will have these heavy metals in it. And then again, we talked about painting. Paints will sometimes have these in, particularly oil-based paints, and also pigments that are used to tint things colors, various colors. The problem with these metals is that they are bioaccumulative. So if you breathe in vapors and these metals are present, those metals are going right into your body. And they are very, very, very difficult to get out of your body. They hit a certain level of contamination, your body hits a certain level, you start having health impacts. Lead is probably the one that most people are familiar with, that even a small amount of lead exposure can lead to blood cancers and brain damage, neurological challenges. Mercury kind of falls in that same category. Chromium, cadmium, antimony, vast majority of the rest of them lead to elevated levels of cancer. So these are not anything that you want to mess around with. If you do have welding or you do have soldering practices that you're teaching students, please make sure that you've got adequate ventilation and that you're sucking those fumes away from the students and yourself. The pigments that we typically see are in cement or oil-based paint, as I said. One of the other things that I wanted to give you a heads up about, because OSHA is looking at this very, very closely, is the dry dust that comes from either concrete work or ceramics work. I had a long discussion with the art teachers about this. Anytime we're aerosolizing or suspending that dry dust, we have exposure to silicates. The OSHA standard now recently changed that the industrial hygienists have determined that the level of silicate that you can be exposed to safely is 0.05 parts per million. 0.5/100ths of a grain of sand. That's it. And the reason is because we're seeing elevated numbers of folks that have done concrete work for a very long time with lung issues. Lung damage leading to COPD, lung cancers. Silicates are very, very small, dangerous particles. When you breathe them in, they go into the deep, deep lobes of your lungs. And again, they're very difficult. You cannot remove them. There is no way to get them out of your body. So please, if you're using any of these processes, make sure you're thinking about that. Am I exposing myself? Am I exposing my students? Is there something I can do so I'm not breathing this stuff in? We've talked about acids. We've talked about inhalation risks. I've shown you what sections of the safety data sheet to use to assess toxicity. There are a lot of other risks in CTE industrial tech that I'm not going to have time to cover today. Lacerations and avulsions, so cuts, that seems to be a high level of concern in industrial technology. Acid exposure, particularly to battery acid, eye injuries, and then fires and flash explosions. All of these are additional concerns in addition to just the chemicals that you're using. So please, as you're going through your processes and you're getting prepared to come back in the fall, or you're buttoning things up for the end of the year, please really evaluate. Are the practices that you're doing, are they too risky for the projects? Are there other alternatives that you can select? One of the ways that we address this, and this is a requirement for schools in both Vermont and New Hampshire, is by including prevention strategies in what's called a chemical hygiene plan. Chemical hygiene plan is defined in OSHA, and in OSHA, it's targeted predominantly at labs. In both New Hampshire and Vermont, however, maybe not Vermont, in New Hampshire specifically, I know that for sure in New Hampshire, the Department of Education has taken that section out and emphasized it in code and said, you know what, you're going to have a chemical hygiene plan. And it's not just for labs. It's for any place where students and teachers are working with flammable liquids, acids or bases, or any chemical processes that can damage them or harm their health. So if you are asked to sit on a chemical hygiene plan committee, there are models of how to write those out there, but that's where you establish, okay, how am I going to evaluate the risk? And how am I going to make sure that if I do bring in a chemical with risk, that I'm going to protect myself and my students? I want to just say I want to just discuss real briefly purchasing practices. When you are purchasing chemicals, so if you're getting ready for next fall and you're purchasing chemicals for next year's classes, please make sure that you check your inventory and only keep 2 to 3 years of inventory on site. Any more than that, and what we found happens over the years, is that the chemicals build up, they become unusable, staff changes, practices and projects change, and we no longer want those chemicals, and then we're left with a mess to clean up that becomes very expensive. So as you're ordering for next year and preparing to get new projects in place, please make sure you're only ordering what you need for a maximum of 3 years. Try to order only compatible products and preferably from one vendor. Please be really careful when you're ordering. If you do any ordering from online large suppliers, a lot of times the chemicals that you receive will not come with safety data sheets. They won't come with adequate information to help you evaluate risk and protective equipment. So please be really cautious if you're ordering from online sources. Make sure that you are not mixing any chemicals unless they're clearly supposed to be mixed together. I've listed for you both in the question and in the question and answer area, as well as on this slide, some different resources. One of the ones I want to call out specifically is the youngworkers.org. So it's developed in California, and they actually have a program called Your Career in Technology Education Safety Program. It is really outstanding. I would encourage you to download it, and you may even want to consider adopting some of those practices. If you have products that you're using and you cannot find the safety data sheets, you can look at the individual ingredients and pull up safety data sheets by ingredient at sigma.com. It's the best source of safety data sheets that I've found. It's international and they're very thorough. There's also examples of student safety contracts at flintsci.com. If you're not currently having students and their parents sign a safety contract about safe management and operation, following directions, and using chemicals and equipment safely in your classroom, I'd really encourage you to think about implementing that. It makes a big difference in due diligence if there is an accident in your classroom. All right, this is our last webinar for a while. We have 2 that are coming in August that are targeted at fire inspectors and insurance inspectors, and I can't remember what else at this point in time. But steps that you can take today: take the time to recognize and assess the chemicals you're using. Look at the safety data sheets for information. It was a shock to me when I pulled up the methanol safety data sheet and looked at just how risky my windshield washer solution was. Do I still use it? Yeah, I do still use it. Am I much more cautious about making sure I don't spill it on my hands or breathing those vapors in? Absolutely. If you have a project where risk exceeds the value, work to minimize your risk. Are there easier, greener, safer products you can use? Is there a way that you can add ventilation into your classroom? What other safety measures can you implement? Make sure that you have a complete inventory of the chemicals you use and the safety data sheets associated with them. One of the skills that would be really valuable for your students to learn is how to read those safety data sheets, particularly if you're teaching high school students or students that are just getting ready to move into careers. The ability to read and assess risk using a safety data sheet is critical. And it's one thing that most companies do during their onboarding. And then make sure that you have the ability to contribute information on how you manage risk in your classroom to the school's chemical hygiene plan. All right, that's all I've got for you today. This is contact information for me. You've got my email address, my phone number, and my website. I am hoping to post all of the webinars on the website. I'm working on it. Just, you know, time is a precious commodity, but I'm getting there. If you have any specific questions, please either reach out to me, or we've also got the next 20, 30 minutes available. So if you have any questions, you're welcome to type them into the question and answer. And I'm happy to share information with you as much as I can. All right, please reach out if you have anything specific that you need guidance on. Anybody have any other questions? Any questions today? Okay, thank you so much for your time. I truly appreciate it. I hope the rest of your school year goes wonderfully and that you have a great summer. Thanks again.
Becky, you just got a question that came in.
Oh, where did it come in at?
Uh,
Oh, there, I'm sorry. Oh, I missed a couple of those. Okay. Let's see, GHS hazard and precautionary statements listed are required in label. Yeah, that's very true. The hazard and precautionary statements have to be on the label. And the labels need to be on the containers. We cannot just put the piece of tape on them with the chemical name. Safety data sheet. I've got Heidi has a question. I thought safety data sheets need to be available in the yellow SDS binder in addition to electronic or Google searching. OSHA made a determination at the federal level that you can have just electronic safety data sheets. The key is they have to be accessible at all times. I encourage most schools to go ahead and print out hard copies and keep them in the SDS binder. There may be a specific requirement at the state level that I'm not familiar with, but I know federally electronic is acceptable. But again, I encourage most of my business folks and my schools to go ahead and print them out. And then Elise had a comment, they're making some seriously competitive carbon dioxide dragsters and getting into the painting process today. Very exciting in the 6th grade classroom. Those CO2 cars are a hoot. So I hope that all goes well. All right, does anybody else have any other questions?
a follow-up one came in.
Oh, there.
Suzanne.
How do you get them all in a small container? Oh, Suzanne, that is a question. In fact, we've actually approached, not me, but my colleagues have approached OSHA in Iowa and said, how do you want us to put them on? Like, let's say they're in a standards vial or a 4 mil GC vial in industry. And OSHA's response a couple of years ago, and I don't know if it's changed or not, was, well, you need to make a really long, skinny label, put all the information on it, and then wind it around. And if you notice some of the, like if you purchase pesticides to use at home, they will come in an accordion label. And the reason that they accordion label those is to fit all of the information that is required. So we don't have any good information or good answers for that right now. And I don't know of any new interpretations from OSHA at the federal level that's addressed that. That's one of my to-do list items for this summer. I would say do your best for right now. I don't know. There's no good answers on that one, and I'm sorry. All right, let's see. I'm sorry, Daniel, I got to keep scrolling down. Okay, under purchase practices, order compatible products, preferably from one vendor. Can I give an example of that? So, one of the things that I've seen a lot of schools have success with over the years is if they find one like art supply place or one automotive supply place that they know will provide them with safety data sheets and with manufacturers guidance. And specific examples, there is for any art supplies, painting, like things like that. And the previous webinar for the art teachers, there's a company called Golden Artist Supply, and they are outstanding at providing guidance, safety data sheets, and safety information. So Golden Artist Supply, I believe, is one. If I come up with any others, or if you have any specific questions, send me an email and we'll see if we can come up with one. For science, chemicals, Flynn Scientific is one of my favorites, as well as Sigma, because they do provide excellent quality information. And accordion labels are a nightmare. I agree with you. I've had some discussions with some of the OSHA inspectors around here, and I was not able to get anybody to budge on any other interpretations. So I'm hoping that I'm really hoping that maybe we get some good guidance, but the last time I focused on that, it was probably 4 or 5 years ago, so it may have changed, but at that point in time, they were advising accordion labels. Or labels they said wind them around the vials. And I said, so they look like tops, like they have wide paper rolls on them, and they said, yeah, that'll work. That doesn't work at all. So challenges, we have a lot of challenges there with what the law says and how we can actually fully comply with it. Big challenges. Anybody have any other questions? Yep, pill bottles, same thing. All right, any other questions from anyone? Please reach out to me if you've got some specific circumstances that you need some guidance on. I'm happy to help as much as I can. All right. Thanks again for joining us, everybody. I really appreciate it.